Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's biweekly contest. Count the number of powerful integers. The problem is yet another application of digitdp. We have discussed digitdp multiple times in the channel. If you have watched any of the previous video, I hope you are able to proceed in this problem at least. If you haven't watched any of the previous video, you can continue with this video, and after understanding what digitdp is, I would strongly encourage you to go through the other videos as well. I will link as many videos I can find in the description down below, so that you can solve those problem and watch the solution if you are not able to get it. So with that, let's get started. The problem states that you are given three integers: start, finish and limit. You are also given zero indexed string s representing a positive integer. Now a positive integer x is called powerful if it ends with s and each digit of x is at most limit. We have to count the total number of powerful integers between start and finish. So let's just take an example. Let's say start is 1, finish is 6000, limit is 4 and s is 1 to 4. What this problem asks, it says that give me the count of powerful integers between 1 and 6000. And what is a powerful integer? Powerful integer is an integer where every digit is less than equals to 4 and the suffix of the integer is 1 to 4, that is the integer should end with 1 to 4. Now because integers should end with 1 to 4, we can simply conclude that integer can't be one digit or two digit, because you can't end with 1 to 4 if you have just one or two digits, right? So integer should be at least 3 digits. Now what are the valid powerful integers here? 1 to 4 is a powerful integer because every digit is less than equals to 4 and it ends with 1 to 4 as well, and it lies between 1 and 6000. Similarly, 1124, 2124, 3124 and 4124 are also powerful integers. Notice 5124 is not a powerful integer because even though it lies between start and finish and it ends with 1 to 4, all of the digit is not less than equals to 4, because the first digit, which is 5, is greater than 4. So 5124 is not a powerful integer, and hence we haven't considered that. So in total we have just this 5 powerful integers, and hence the answer here is 5. So hope the problem statement is clear. Now how to solve this? As always, we will first try to reduce the problem and solve a simplified version of the problem, and then tackle the original problem, right? So before moving forward, let's just do a small observation and reduce the number of variables in the problem. Currently we have just 4 variables, right? So let's try to reduce the number of variables. We can easily reduce these 2 variables into 1 variable. How? I would encourage you to pause and think. So notice we have to find something between start and finish. In other words, we have to find something between L and R, let's say. So if the function is cumulative, whatever you are finding is cumulative, you can simply get rid of these 2 variables and with just one single variable. How? You can say, okay, I will find whatever I have to find in between 0 and R, and I will find the same thing between 0 and L minus 1, and I will subtract these 2 values to get everything between L and R, right? So in this particular example, we will find out the number of powerful integers between 0 and R, number of powerful integers between 0 and L minus 1, subtract these 2 to get the number of powerful integers between L and R. Now how did this help? This helped because now you can simply replace this L and R with a single variable x. You can say, okay, give me the number of powerful integers between 0 and x, and let's say there is a function fx for that. So fx denotes the number of powerful integers between 0 and x. So what you can do, your answer would simply be f of r minus f of L minus 1. So you don't need to actually take care of both L and R while calculating the powerful integers. Instead, you can say, okay, I will simply write a function f that will give me the number of powerful integers between 0 and x, and this will be my final answer, right? So this way you are able to remove these two variables and replace it with a single variable x, right? That is a bit easy to work with. Now we are able to do this because the function is cumulative. The function here is count the number of integers between L and R, right? That satisfies certain criteria. Now if the function is not cumulative, this logic will not apply. So an example could be, let's say you have to find out the bitwise OR of everything or every powerful integer between L and R. So bitwise OR is not cumulative. In other words, if you have bitwise OR of 0 and R and bitwise OR of 0 and L minus 1, with these two numbers you can't find out the bitwise OR of everything between L and R, right? So that's where you can't apply the same trick here, and in that case you actually have to work with two variables L and R always in your solution, right? But in this criteria you have to just count, and count is cumulative, so we are good. So we replaced start and finish with a single variable x. Now for the time being, let's forget about suffix. Let's assume suffix is not there. We will add suffix later. For now we are just solving the problem with two variables x and limit. What does this mean? This means count me the number of powerful integers between 0 and x. What is a powerful integer? Powerful integer is an integer for which all the digits should be less than equals to the given limit, right? So every digit of the integer should be less than equals to limit, and you have to find all such integers between 0 and x, right? So this is the reduced problem we will be solving now before solving the original one. So if you haven't thought about this reduced version yet, I would encourage you to pause and try to think about this reduced version by yourself. So how to solve? What is the brute force solution? The brute force solution is simply, I will iterate over everything between 0 and x. Let's say I am at currently an integer I. So for I will figure out all the digits, or I will iterate over all the digits of I, and for all the digit I will check whether it is less than equals to limit. If it is less than equals to limit, then I will consider I as a valid powerful integer and increment my result. Otherwise I will not increment my result and continue forward. So this way I will be having the total number of powerful integers after iterating from everything between 0 and x. That is a valid solution. What is the time complexity? Time complexity would simply be n into number of digits, and number of digits would be log of n, because you are iterating over everything between 0 and x, which is n. Let's say you have just n numbers, and for each integer you are iterating over its digit, which is d in this case, and d would be log of n roughly, right? So this is the overall complexity of the brute force solution, and we have to obviously do better. We have which of these two factor is bigger? Obviously n. So d is just the number of digits in a particular number. So if let's say n is 10 power 5, d is just 5, right? So you can see n is the biggest factor here. So the solution that we are trying to obtain is without n. It can be of d, it can be of d square, it can be of d cube, it can be a polynomial of d, but it should not include n. So that's what we are trying to target. So how to achieve that? Notice you have d here, right? And you don't want n here. It inherently means that you can't iterate over everything between 0 and x, but you have to just iterate over number of digits in the final result and calculate the answer from that, right? So we have to just iterate over this, let's say 6 digit, this is our x 251197, and let's say limit in the current problem is 5, right? So limit is 5, x is 251197. Now we have to iterate over the digits, basically this 6 digits, and figure out what are the 6 digits numbers which are less than equals to this and has all the digits less than equals to 5. So why 6 digit? Because I am assuming that we will figure out the answer for each digits separately, or digits of each length separately. So we'll figure out the answer for 6 digit, we'll figure out the answer for 5, 4, 3, 2 and 1. So for now we are just caring about 6 digits number, right? So what will be the value here? You can put either 0, or sorry, you can't put 0 here, because if we put 0 it will be a 5 digit number which currently is not allowed. So we have to make 6 digit number. So you can put 1, you can put 2, right, because limit is 5. You can put 3, or can you put 3? The answer is no, because as soon as you put 3, this number, whatever number you will form, no matter what you put here, whatever number will be formed will be greater than this, and that's what we don't want. So you can't put 3 here. Instead there are just 2 possible choices, 1 or 2. Let's assume you put 2 here, right? Now what you can put here? Again this time you can put 0, right? You can put 1, you can put 2, you can put 3, 4, 5, 6. You can put 6? No, because as soon as you put 6, this number will be greater than this, and further limit is also up to 5, so you can't put 6 here, right? So we have the power to put any of these digits. So let's say you put something, let's say 5. Now what else here? So again here you have to go to the same exercise. So what we are seeing is, for any index I, if I need to figure out what I can put here, I need to understand what I have already put before. And if I have put before something which makes the number already smaller than the original number, I don't have to worry about what to put here. Instead I can put anything between 0 and limit. I don't have any restriction, right? For example, in this case, if this is 0, right, let's say you have put 0. So once you have put 0 here, it doesn't matter what you put in these 3 boxes, because whatever you will put, the resultant number will anyway be less than equals to x. So because these 3 are now free, you can put anything between 0 and limit. You are allowed to do that, right? But if let's say you have put 1 here, then you are bounded here. You can't put everything between 0 and limit, because if you exceed this number, then the resultant number will be greater than the original number x, which you don't want, right? So we need a way to answer one thing for a index I. What is that? Whether we have some restriction or we don't have any restriction. If we don't have any restriction, we know we can put everything between 0 and limit. If we have some restriction, then what is the restriction is something we'll figure out, and what to put based on that restriction. Because if we have restriction, we know we can put we have no other choice rather than to put everything between 0 and this particular value, right? So we just need to figure out whether there is a restriction or not, right? So how to figure out whether there is restriction or not? One way could be what we have already filled. If we have filled something which is already less than the original one, then the current digit doesn't have any restriction. But if we have put something for which the current number is equal to x, then we have restriction. Notice that it can never be greater than x, because if it is greater than x, you won't come here, because the number itself has increased. So whatever you will put, it will not form a valid number, right? So in other words, what we are trying to get at is, let's say you have to compare two numbers, right? For comparing two numbers, you just have to figure out what is the first mismatch. As soon as you figure out the first mismatch, you can tell which number is larger. So here this index 3 is the first mismatch, and in index 3 the second number has the greater value, hence the second number overall is greater than the first number. Again, this is with the assumption that both the numbers have equal number of digits, right? Similarly, you can see here, once you figure out the first mismatch digit, that's the point which matter, and based on that you can tell which one is the larger, right? So to answer the question whether there is a limit, whether there is any limit or not, you just need to figure out whether there is a mismatch or not previously, right? If there is a mismatch, then I am very sure that I don't have any restriction in the current digit. If there is no mismatch, then I have a restriction in the current digit. That's it, right? So we can have a simple function f which will take in I, and a simple boolean value which says whether I have a mismatch before I, or whether I have filled a index before I which doesn't match with the original value. If there is, then I has no restriction. If there is no mismatch, then I has restriction. If I has no restriction, we can put anything between 0 and limit in the ith position. If I has restriction, we can put anything between 0 and array of I, where array of I denotes what is the value at the current index, right? So hope this makes sense. Let's just look at one example to make things a bit more clear. So let's say this is your number 231, right? In other words, you need to figure out everything, the number of powerful integers less than 231, and limit is 3, which means for any integer to be powerful, every digit of that integer should be less than equals to 3, right? Now let's start with the first position. So what will you fill here? I can fill 1, 2 or 3 based on the limit, but 3 I can't fill, because if I fill 3, this number will be greater, that I know. So because there is no mismatch before, that's why we are currently limited, and we are limited by this particular value 2, right? So we want to find out f of 0, 0, which means everything starting from 0. I need to fill every boxes starting from 0, and I know there is no mismatch before me, right? So we have just two choices, 1 and 2. Why? Because we are limited by this particular value. So once you put 1 here, let's say you put 1 here, now for this particular index f of 1 comma, what will be the value here? This would be true. Why? Because there is a mismatch, right? So if you put 1 here, now you need to figure out f of 1 comma 1. Basically give me the we have to fill everything starting at index 1, and we already know that there is a mismatch, so everything now is limitless. Similarly, if I put 2 here instead, then the value is same, right? So at index 1, I still don't have any index which is mismatching, so I will simply put 0. Basically I will find out how many ways are there to fill everything starting at index 1 such that there is no mismatch before, right? So let's start with f of 1 comma 1. So we have to find out what is the total number of ways to fill everything starting at index 1, and we already know that there is a mismatch before. So because there is a mismatch before, the current index 1 is limitless. You can put anything between 0 and limit, or in other words 0 and 3. You can either put 0, you can either put 1, 2 or 3, right? Now irrespective of what you put, let's say you put 2 here, doesn't matter, because you already have a mismatched digit before. This was 1, right? So you already have a mismatched digit before. You will still have one mismatched digit before, right? So even though the current thing you matches with this one, let's say this is matching, you still have a mismatched digit before. So that's why we, for every possible options that we can fill, for everything we will just ask for, okay, I have to fill everything starting at index 2, and I'm sure that I have a mismatched digit before. So basically everything starting at index 2 is limitless, right? So let's try to figure out f of 2 comma 1. So everything is f of 2 comma 1, so we'll just figure out f of 2 comma 1 once and just sum them all up. So what is f of 2 comma 1? Basically it says I know that, like, find me the number of ways to fill this particular index, and I already know that there is a mismatch before then the current index. So what will be the total number of or what will be the choices? Because there is a mismatch digit, this is limitless, so you can put either 0, 1, 2 or 3, right? So similar to this you can have 2 as well, which will also say f of 3 comma 1, right? And you will have 3 as well, which will also say f of 3 comma 1, right? So what will be the value of f of 3 comma 1? It says that find me the number of ways to fill the third box or the fourth box, and I already know that there is a mismatch before, right? So basically filling up fourth box, it means that we have already filled all the boxes before. So f of 3 comma 1 is simply 1, right? So value of all of these is 1. So f of 2 comma 1 is simply 4, right? Now f of 2 comma 1 is 4, which basically means all these values are 4, which in turn means f of 1 comma 1 is 16, right? Now what is f of 1 comma 0? Again f of 1 comma 0, it means that sorry, so f of 1 comma 0, let's just try to figure out that. So let's say currently you have put 0, 2 here, right? 1 comma 0 states that you have to put something at index 1. Now we are sure that there is no mismatch before me, that's why this value is 0, right? So what are the number of ways to fill everything after index 1 such that there is no mismatch before? So again there is no mismatch, so I am bounded by whatever is present here. So either I can put 0 or 1 or 2 or 3, right? So one of these three values. Now let's say you put 0 here, then there is a mismatch, so this will become 1, right? If you put 1 here, again mismatch. If you put 2 here, again mismatch. If you put 3 here, there is no mismatch, right? Because previously as well you have put 2 in the first position, now you are putting 3 here, so there is no mismatch at all. So because there is no mismatch, you will say find me the number of ways to fill everything starting at index 2 such that there is no mismatch before. So f of 2 comma 0, and in the same fashion you will figure out f of 2 comma 0 as well. In this case, because there is no mismatch, you are limited by whatever is present here, right? So you can either put 0 or you can put 1, so you have just these two choices. So this will be 1, this will be 1 as well. So value of 2 comma 0 is 2. These three we already know, these are the values 4. So 12 plus 2 14, and 14 plus 16 is 30. So basically there are 30 such there are 30 powerful integers which are less than equals to 231, where powerful integer is defined by all the integer where all the digits are less than equals to 3. So hope this makes sense. What will be the pseudocode? The pseudocode would simply look like this. We will have a function which will say find me the number of ways in which I can fill everything starting at index 1, index ind, such that there is some mismatch before or not, right? So as we have seen that we have to compute we may have to compute the same state again and again. So f of 2 comma 1, f of 2 comma 1. So we will simply do memorization here to avoid computing the same state again and again. We will save the value once we compute it, and before computing any value, we'll just look whether we have saved something here or not. If we have saved, we will use that, otherwise we will compute. Now, how to compute? As mentioned, we at current position, there are two choices: either it is constrained or it is not constrained. So if it is constrained, it means there is no mismatch. There is a mismatch before, then you can put anything between 0 and 9. If it is not if it's constrained, then you have to put everything between 0 and val of index. Now whatever you will put, you can't go beyond limit as well. That is another constraint, right? So this is the maximum value you can put in the current index given the particular state of whether you have a previously mismatched index or not. And similarly for starting, this is the one which you will start with. Basically, if the index is 0, it means you are starting with you are filling the first index, so it can't be 0. So that's why if it is 0, you will start with 1, otherwise you will start with 0. So you will try to fill everything between start and index, and for each one you will simply call the same function with new is smaller, where new is smaller will denote whether there is a mismatch or not after the current substitution. So if you substitute something I here, so you will have to now figure out everything. You have to fill everything after index plus 1, right? So let's say this is index and you have put I here, so you have to now fill everything after index plus 1. So for index plus 1, you have to know whether there is a mismatch previously or not. So you already know whether there is a mismatch previously or not by this is smaller. So if there is a mismatch already, you don't need to worry about it, because there is already a mismatch, so there will be a mismatch, so it will be true. But if there is no mismatch, then it boils down to what you are putting here. So if the value of the original number x is not equals to the current value, then there is a mismatch, otherwise there is no mismatch. So that's what we are checking. If it is less than the value of index, then there is a mismatch and we will simply make it true, otherwise there is no mismatch, right? So once we do this, we will simply call f of index plus 1 with the new is smaller and keep adding this for all the valid digits we can put at the current index. And finally we will also store it in our db array so that we can reuse it if required. So this will give you the total number of powerful integers which is of some length L, right? Notice this is of a particular length. So but you need number of powerful integers between 0 and x, right? Now x is of some length, so for x length you know what is the answer. So what you will do, you will simply say I will iterate over everything between 1 and x dot size, and for each of them I will figure out what will be the total number of powerful integers between 0 and that particular size. So basically, let's say in the previous case x was 231, so you will first figure out the total number of powerful integers between 0 and between 0 and 231, which is of 3 digits. So 3 digits powerful integers are 30, but there can be 2 digits powerful integers as well, and similarly there can be 1 digit powerful integers as well, which we haven't considered here. So we have to consider them as well, right? So we will consider both of them one by one and add that to our result as well, right? Notice there the actual value x will change. So here the x is 231, but when you come to 2 digits, x will be 99. and when you come to one digit, x will be 9. Why? Because you want everything to be less than 231, and if the number of digit is already lesser, then there is no limit at all. Rather, you will take the largest value of that digit, right? So hope this entire thing makes sense. So we have just solved what is the total number of positive powerful integers less than equals to x, where powerful integers is defined by all the digits should be less than equals to the given limit, right? But if you remember, the original problem asked us that there is a suffix as well, right? So till now whatever we have been solving, we ignored suffix completely, but original problem states that the number or the powerful number should end with a particular suffix. If you just look at the example again, there is a string s which denotes what will be the suffix of the powerful integer. So all the powerful integers that we have should have that particular suffix. So let's just take that constraint back in and try to solve that problem again. So if you have watched this point, I am very confident that if you pause the video and think for a moment, you will be able to at least make some progress on the original problem. That is the same thing with just one extra condition, that is the number should end with a particular suffix, right? So let's discuss that as well. Let's say we have the exact same thing. Limit is 3, the number is 231 or x is 231, and this is the suffix. The number should end with 11, right? And notice we are only currently calculating 3 digits positive in powerful integers. 2 digit, 1 digit we will have to compute as well. So in this case you don't need to compute 1 digit powerful integer because the suffix itself is of size 2. So you will just say I will figure out the number of powerful integers of 2 digits, number of powerful integers of 3 digits. For 2 digit the value of x would be 99. For 3 digits the value of x would be 231, right? So now how to figure out this? So again, this is very straightforward. We will follow the exact same thing. Only thing that changes now is what we can put in the last 2 cells. Previously we have some values. Either you can put anything between 0 and limit, or you can put anything between 0 and val based on whether it is restricted or not. But now, irrespective of whether it is restricted or not, you have to put 1. There is no other choice. Now this also bring one more question, that if you are not allowed to put 1, let's say you just have to you are only allowed to put 0 here. So in that case you will simply say whatever you have filled so far, or the number of ways to fill everything afterwards is 0, right? So let's just take one more example and this will make things much more clear. So again we have to figure out how many ways are there to fill everything after index 0 such that there is no previous mismatch, right? So f of 0 comma 0. So here we can first put 1 and 2, 1 or 2. We can't put 0 here because this is the first digit, so either 1 or 2. So if we put 1 here, there is a mismatch, so this will become 1. If we put 2 here, there is no mismatch, so it will remain 0, right? Now if you put 1 here, there is a mismatch. Now what you will put here, because there is a mismatch already, this is unbounded. You can put either 0, 1, 2 or 3, right? But because you have to follow a suffix as well, among all of these you can only pick whatever is present in the suffix. So if suffix has, let's say, 41, then there is no choice here, and you will say for f of 1 comma 1 the value is 0. In other words, number of ways to fill everything starting at index 1 such that there is a mismatch before is 0, because you can't fill anything because suffix says it should be 4, but your allowed values are 0, 1, 2 and 3, right? So in current scenario it is 1, so 1 is allowed here, so you will put 1 only. Notice you can't go to 0, 2 or 3. You can't put any of these. You can only put 1 here. Now once you put 1 here, because there was already a mismatch, so it will remain 1. The second parameter will remain 1. Basically you will say find me the number of ways to fill everything after index 2 such that there is a mismatch there is already a mismatch before. So again, because there is already a mismatch, this is unbounded. You can put anything between 0, 1, 2 and 3, but this is again 1, so this says you have to put 1 here, and because 1 is allowed, you can put 1 here. Luckily, notice you can't put 0, so you can put 1 here. So the value of f of 3 of 1 is 1, we know. So f of 2 of 1 will also be 1 now, and f of 1 comma 1 will be 1 as well. And in the same fashion, if you go this route, this as well, if you see, this will come as 1, this will come as 1, and this will come as 1. But this 1 will not be contributed because you can't put 3 here, so overall this will be 1, and the value of 0 comma 0 would be 2. So basically they are just two integers or two powerful integers which satisfy the condition for being a powerful integer. And what are those? They are 1 1 1, 2 1 and 1, right? And you can see 1 1 1 and 2 1 1 are indeed the only two integers that ends with 1 1, and every digit is less than equals to 3, right? So again, the problem actually asks to find out all the things between 0 and x, right? But we just figured out the number of powerful integers that are of length 3 in between 0 and x. So for length 2 we have to repeat the exercise, and for length 1 as well we have to repeat the exercise. In this scenario we don't have to consider length 1 because the suffix itself is of length 3. So how will the pseudocode look like? The pseudocode will simply be modified with one single criteria. Everything is as it is. It's just the modification of st and ed, basically what you can put in the current digit. So if the index is under the suffix length, then you are bound to put a single value here. So you at the end st will be equals to ed, but you also have to intersect it with the existing numbers because you want to know whether you can put anything here or not, right? So that's where this max and min comes. You can write it in different ways, but at the end st will be equals to ed, and you have to just decide whether that number lies between the original st and ed, whether that number is allowed or not, right? And if it is allowed, you will continue, otherwise you will not continue, right? And if you don't continue, the answer will be simply 0. So hope this makes sense as well. So let's just quickly reiterate over the complete solution before jumping to the code. So we started by saying that we will not consider start and finish separately. Instead we will say I will first figure out a function f of x which will give me the number of powerful integers between 0 and x, and the final answer would be f of finish minus f of start minus 1, right? So we will simply wrote this function. Now this function in itself is classified into different segments. First one, we will say how many powerful numbers are there with length L. Then we will say how many powerful numbers are there with length L minus 1. And in this case, we will say how many powerful numbers are there with length L that are less than equals to x, right? For L minus 1, we don't have to consider x because the length itself is decreased. So we will simply say less than equals to 9999 all the way up to L minus 1, right? And similarly for L minus 2, L minus 3 and so on and so forth until suffix dot length, because that's the minimum length you can have, right? So hope this entire solution is clear. If you have watched to this point, I would strongly encourage you to pause and code this entire thing by yourself, because that's what will give you much better confidence and you'll be able to retain what you have learned for a longer time. I have intentionally put something in the pseudocode as ambiguous so that you have the opportunity to think while you are writing the code. So next we're looking at the code. Again, I would encourage, if you haven't tried it yet, you should pause and write, or at least try to write by yourself. So the code is exactly what we have discussed. We wrote a function f which we named up to x, and we simply say up to of finish minus up to of start minus 1. Now what we have in up to, we will simply check if the length of the string or the length of x is less than the suffix. In that case you can't create any number at all. Suffix itself is greater than what the maximum value you have, so you will simply return 0 in that case. Otherwise you will iterate over all the possible lengths. So what are the possible lengths? Everything starting from suffix all the way up to max length. So for everything which is less than max length, you have all lines. So we'll pick all lines as max value or the value of x, and we'll simply figure out the positive and the powerful integers. And for the length, max length, you know this is the exact value of x with which you have to be, the final number should be smaller than that, and for that you again find out the powerful integers. So powerful integers looks something like this. If we exhausted the entire string or we have filled everything with some value, then we actually have a valid number, so we'll simply return 1. Otherwise if we have computed this state, we'll use that particular answer. Otherwise we'll compute it. In computation we will simply find out the start and end based on whether there is a mismatch or not. If there is a mismatch, then we are limitless. Otherwise there is a limit on max value, and there is an overall limit of limit as well. Now if that's not the case, we will also see if the current index lies within the suffix part. If it does lies in the suffix part, we will simply update our start and end, because that means you just are allowed to put one single value, and that too if it is allowed previously or not, right? And based on that we'll simply figure out the new smaller and call the same function. So hope this entire solution makes sense. What is the time complexity? So time complexity is straightforward. You are calculating something, or first of all, how many things you are calculating. You have some d number of digits, and for each of them each smaller can have 2 values, so the total d into 2 states you will be calculating. And for each of these states, what you will be doing, you are iterating over some digits. So in total you can iterate over 10 digits in worst case. So complexity is simply order d itself for a single iteration. Now you are doing this for all the lengths, so in their total d lengths, so you will be doing it d number of times, so order d square is the overall complexity. In the current problem, d is just 15, so 15 square. So the same solution would work for 1000, 10 power 1000 or 10 power 4 as well. So if you like the video, give a thumbs up and do subscribe if you haven't already. As mentioned, I will link other DGDB problems in the description below. Make sure to check them out, and I'm very sure you'll be able to learn something new from those as well. And I will see you in the next one. Thank you.